Hello everyone. With this lecture, we are going to start talking about nested subqueries. Okay. Now, what are nested subqueries? So, in nested subqueries, what we basically have is that we have an select from where expression nested inside another query. Right. So, this is what is broadly called as nested subqueries. Right. And we are going to spend considerable amount of time on this, and they are intuitive, but you'll have to grasp it nicely. Okay, so let's start. So consider this typical query: select some projection of columns a1, a2, an from maybe some m relations we have here, and then there is a where clause. Now, ideally speaking, you can have a nested query in either the select part, from part, or where part, or in fact all three, right? So right, but when you are replacing these this a1, a2, and all these things with subqueries, there are some things which you are allowed to do and some things which you are not allowed to do. So for example, if you are replacing this a1 with a subquery, then there is a constraint that it should be returning a single value, otherwise it's erroneous, right? And in the from clause, instead of this r1 or r2, you can keep an subquery, right? And this is actually, in my opinion, one of the most intuitive ways, because you might remember that I said both in relational algebra and SQL, conceptually we always say that an SQL query or relational algebra, it takes some relations and it throws out some other relations, right? So we are, when we replace this R1, R2 or Rm with a subquery, we are quite literally doing that. Now we are, instead of a relation, we are using the output of an SQL query as a relation, right? And then maybe perform some other joins and all that, right? And where using n subquery in where clause is also quite intuitive. Here your subquery is of usually of the following form, right? So you have some some attribute b, some operation like less than, all, or there are some specific keywords also here. We will go deeper into this aspect, followed by some subquery, right? Okay, so just to give you a high level view of nested subqueries, we are going to, so this lecture is sort of divided into three parts. So in the first part, we are going to talk about using subqueries in the select clause. And in the second part, we are going to talk about using subqueries in this relation in the from clause. And last but not the least, we are going to talk about using subqueries in the where clause, right? So we'll be covering all these three with good examples. Okay, let's start. So nested subqueries in the when we are using subqueries in the select clause. Okay. Okay. Now let's see this example here. What do we have? So our question is, we want all the departments, and for each department we want the number of instructors in that particular department, right? Of course, there is more than one way of solving this, but I just want to illustrate the subquery in the select clause. Okay, so let's see how this is being done here. So as I always say, the first thing, given any SQL query, you first start from the from clause, the grand data set or tables that are of interest to us, right? So for this particular query, we want the department numbers. Okay, so I just say that from department, that's it. We are going to loop over each tuple of the department relation, and then for every tuple of the department relation, I am going to perform the select clause, or I'm going to perform the projection operator. Now, what do we have in the projection operator? So the first thing is that for every tuple of the department relation, you're just going to print the department name. That's easy. And the second one, what you're doing is you are passing this department name into an another subquery. And what is the subquery doing? So it is going to see all the tuples from the instructor relation, and then for this given particular department name, right, it's going to filter out the tuples from the instructor relation where the department name in the instructor relation corresponds to the current department which you are processing from the from clause, right. So let's say that you have in this department relation you have three departments, tuples corresponding to only three departments: computer science, mechanical, and let's say electrical, right. So three tuples, so you pick one at a time. Let's say that you first pick the mechanical tuple. So for that tuple you will go towards go to the select clause. In that select clause, what would you do? You're going to print the department name, mechanical department, and then you're going to send that department name into this subquery. And what is this subquery doing? It is looping over all the tuples of the instructor relation and then checking where all and checking for all the tuples where the department name in the instructor tuple is equivalent to the mechanical name. In the department name in the instructor tuple contains the phrase mechanical, because that is the current tuple that you are processing from the, so for lack of better words, let's say outer query, right. And you will filter out all the tuples from the instructor relation where the department name is mechanical for the first iteration from the outer query, right. And for all those tuples you are going to just count the number of tuples that are returned by just doing count star, and then you print it, right. So remember that this tuple, this subquery is going to be executed for every tuple in the outer query, right. So that means this guy, select count star from instructor where instructor dot department name is equal to department dot department name. This query would be executed for every tuple of the department relation. It's like a nested query, right. And after, and what is the output of this query? This query outputs a single number, because remember that this select clause, when you do the projection operator, right, these things they are done for every tuple. For every tuple you pick a column, right, and you for one tuple of the department relation you pick the department name. You can so this entire subquery should return only one item, either string or integer, float, whatever it is. It has to just return one value. If it returns more than one value, then that is going to be an conceptual mistake, right. So that's what I'm writing here, is that this query is going to give you a runtime error if the inner subquery returns more than one result in the tuple, right, because that's logically incorrect, because this is in the select clause, right, and always in the select clause you solve it, you make the projection for every tuple, right, and the result of that projection should be always a single value. So if you are writing a subquery in the select clause, it has to return a single value, otherwise it's conceptually wrong. Okay. So again, just take your time and try to understand what is happening, right. So the key thing to remember is that this inner query is going to be executed for every tuple from the department relation. It's like a nested loop, so to say, right. So this was an illustration of scalar subquery or subquery in this select clause. Okay, let's go forward. Now we have subqueries in the where clause. So this is going to be slightly bigger, and of course we'll have a lot more examples also here, right. So when you are using subqueries in the where clause, you are basically using it for some kind of a test, right. And if you remember, if you try to recall the grand scheme of where clause, what did it do? You used to take every tuple that gets generated from the from clause, and for that tuple you're going to evaluate some boolean conditions which were written in the where clause, right? So that is the position in which where clause comes in. Now this evaluation of certain Boolean condition, you try to throw in subqueries into that, and you can do different kinds of tests. So for example, you can do set membership, set comparisons, cardinality. Let's take an example from these, so hopefully then it will be more clear. Okay, so you might remember this query. We want to find all the courses which were offered in fall 2009 and in spring 2010, right? So previously we, I think, used the intersect operator to perform this. Let's try to see one more way, right? So let's see how we are doing. As I always I say, you start from the from clause. So I'm going to loop over all tuples of my section relation. Remember that whenever a course is offered, a tuple gets inserted into the section relation, right? And you're going to loop over all the tuples of the section relation, and then for every tuple of the section relation, I am going to check this where clause. Now let's see what does this where clause do. Okay, so what it is going to do is, first thing, we have to we need the courses which were offered in fall 2009, right? So that means for a tuple to pass, you have to check whether the semester was indeed fall and whether the year was in 2009 or not. That's the first check that you do. And the second check, and in the second check we are sort of inserting the subquery, right? So so after you check both of these, then you go for the course ID in that tuple from the section relation, right? Because if you, let me quickly show you the schema again, right? So in the section relation, you had course ID, section ID, semester and year, right? So for semester and year, we want fall 2009, but for this course ID, we want to check if this course ID was offered again in spring 2010 or not, right? So let's go back. Okay, so for checking the second part, we are using the subquery, and how we are using it, we'll check if the course ID in this particular tuple of section, if that course ID comes, falls in this set or not. And what is this set? So this set contains the list of all the course IDs from the section table which were offered in spring 2010, right? So this red query is that set. It is the set of all course IDs where, which were offered in spring 2010. Now, when you are checking a tuple here in the outer relation, right, and you check this course ID, this keyword is important, in. So in is something which we call as a set membership. Now, in is used for checking set membership. You check whether the course ID in this tuple is going to be is present in this set or not, right? So again, the nested subqueries, conceptually you can always see them as nested queries, conceptually. Implementation will come to that later, right? But conceptually, what we can think is that this query, let's say that it is executed for every tuple of the outer query, right? And every time you take a tuple from this guy, you put some where clause to it, and then in one of the Boolean conditions, you check whether this attribute happens to be present in this set or not. Now, implementation wise, this query is sort of independent of this query, so this can be executed before, and just query optimizer may just execute at this red portion and keep it as a temporary relation. But nevertheless, conceptually, you can see that this checking is done once for every tuple, right? Because sometimes this inner query may take something from the outer query also, right? I think we have examples of that as well. Hopefully this is clear. Next. Yeah, this is another example. find courses which were offered in fall 2009 but not in spring 2010, right? Essentially the same query, instead of in, I am using the keyword not in, right? So I am going to loop over my tuples of the section relation. I will check whether the semester is fall, the year is 2009 or not, and then for that tuple the course ID should not be in the list of courses which were offered in spring 2010, right? So this inner thing is considered as a set, and we check whether this guy is present in this set or not. If this guy is not present, then this whole Boolean condition, this part, is evaluated to true, otherwise false. In the previous case, if the course ID falls in this set, then this whole Boolean condition, this part, evaluates to true, right? So that's the way to think, because in where clause, remember that these all are Boolean conditions, right? Semester equal to fall was a Boolean test, year equal to 2009, again a Boolean test, course ID not in this, again it has to be a Boolean test only, otherwise it's a logical error, right? Okay. Now just another example, that this in clause, when you are testing for SQL, when you are testing for set membership, you can, instead of a single value, like for example here I was using a single value, course ID, I was checking whether in this set or not. Instead of a single value, you can put a tuple also, right? So here we are checking course ID, section ID, semester and year in the set, and over there that set is also an it's a set of tuples. So the key thing is that whatever you are writing before in, right? So the same schema should be reflected in this query also, right? For example, I cannot write here where course ID and delete all of this and then write here select course ID, section ID. No, that is wrong, right? So for example, if I had written select course ID and section ID and all that, then that is wrong. Then that will not be a valid comparison. You have, when you are checking for course ID in this set, the set should also contain a list of course IDs only. Otherwise, it's going to be a semantic error, right? Okay, so this is an example, as I said, where the inner set is consisting of tuples rather than individual values. Okay, and then as you can check, this part and this part should have identical schema. Otherwise, it will be a logical or semantic error. Okay. Okay, so that was about set membership. Okay, now some examples on the set comparison operators. Okay, you might remember this query from before. We wanted to find all the instructors from the instructor relation whose salary is greater than at least one instructor of the biology department, right? And we tried to solve this query using self join. Just another instance of how you can do this query. You can do this query using subqueries, and this is how you do. You're going to loop over all the tuples of the instructor, and for every tuple you check, you take the salary attribute and you check if it is greater than sum, right? So that's the key here, sum. So here what we are doing is that in the inner subquery, this the one inside the bracket, I'm picking all the salaries from the instructor relation where the department name is biology. In other words, this inner subquery is list of the salaries from the biology department. And now, when we are looping over this outer subquery tuples, for each tuple, you pick the salary and you check if it is greater than at least one item from this inner set, right? So just to give you an okay, so just to give you an example, just let's see this part. So 5 greater than sum, and this is the output of the inner query, let's say, right? So there exists at least one item in this set which is less than 5. So that is, this is why this is going to give you true. So for example, if I had changed this like this, 5 less than sum, this is going to be false, right? Because there is no item in this inner set which is greater than 5, right? So they all are either less than or equal to. Okay, similar is the story here. So 5 is less than sum from this inner set, right? So there is at least one item here which is greater than 5. So that is why this Boolean condition is going to be true. If you had written like this, then this would also be true, because there exists at least one item which is smaller than 5, right? So that this is how the sum operator is going to work out. Okay. Okay. So another keyword. So now instead of sum, let's say we have this keyword all, right? So let's take an example how that works. So we want to find the names of all the instructors whose salary is greater than the salary of all the instructors in the biology department. If I had something like this, then I can use the keyword all over here. So I'm going to loop over the tuples of the instructor relation, and for every tuple I'm going to check whether the salary in that tuple is greater than all the items which are there in my inner query, result of the inner query. And what is the inner query? So inner query contains a list of salaries from the instructor department where the department name is biology. In other words, the inner query is basically list of salaries from the bio department, right? And then you're going to check for every tuple in the outer relation, you're going to check if the attribute value in that tuple is greater than all the values of the inner query. Just to give you a little bit more example, I took it from your textbook, right? Okay. So again, you can check like this: 5 less than all. This is false, right? Because there are two items here. Sorry, there are two items over here, for which this is not true. 5 is not less than 0 and 5 is not less than 5, right? Similar is the case. So you have to be little bit careful, to make sure that you get the correct interpretation, right? So something like this is quite straightforward. You can check 5 is less than all of the items in this set. This is true, right? So just be careful, otherwise you may make errors. Okay. And I think in my experience, instead of I think for the queries which I have given to students in past, I think students were using this all operator lot more than the sum operator. Okay. So this was about set comparison, right? Now the last part, we'll check subquery, or we will use subqueries to test the cardinality, or to perform some kind of an cardinality test. And remember that I'm going to stress this again. Uh, all of this subquery and all that, this is, at the end of the day, it is just one Boolean test condition, right? This salary greater than sum, all, whatever you want to write here, the whole of the story should either evaluate to true or false. There should not be anything else in the between. Otherwise, it's going to be a logical error. Okay. So now let's go for subqueries where the cardinality of the inner relation starts to mean something, right? So let's check this. Again, I'm going to this question, find all the courses which were taught in both fall 2009 semester and spring 2010 semester, right? So here I'm going to use the keyword exists, right? Uh, Again, straightforward. In the outer query, you're just going to loop over all the tuples of the section, and note that I have created a copy of this section and I call it as S. So S is a copy of the section. table on the outer relation, and for each tuple in this S, I'm going to perform the following checks. So first check is whether semester is fall or not, whether the year is 2009, and I'm writing this keyword exists. Select star from section as T. So this is a different copy of this section table, right? Where semester is spring, year is 10, and then just check this part. S dot course ID is equal to T dot course ID. Now this is interesting. So here what we have done is that we are going to loop over all tuples of the outer relation, and then I am passing a tuple from the outer relation or outer query. That's the right way to saying that. We are going to pass a tuple from the outer query into the subquery, right? So this S dot course ID refers to the current tuple which is being evaluated in the outer query. Again, this is you can very much take it as a nested loop. You're going to loop over all the tuples of the section relation, and for every tuple in the coming from the outer relation, you pass that tuple to the inner query. So in this case I'm going to pass S dot course ID. I could have used S dot course name or whatever. The entire tuple is basically passed inside, and then using that you're going to perform some checks, right? And the checks, that to be more specific, the checks that we are going to perform in this query is we'll check whether the inner relation is returning a non-null value. That's why this keyword exists is written. So the way exists is evaluated is that it evaluates this inner query for every tuple from this guy, and it will check what was did the inner query return an non-null answer. If it returns a non-null answer, then this whole condition boolean, this part, remember this is a part of the where clause, so at the end of the day this has to return true or false. That's it. When you are writing like this, exists followed by a query, it checks whether the inner query is returning a non-null answer. If it is returning a non-null answer, then this whole Boolean condition is evaluated to true. And when it evaluates to true, then the current tuple which is being processed in the outer query is returned to the final answer. I means it's actually passed on to the projection operator, and you do some projections over, right? So that's how this exists work. And this particular query also uses a tuple from the this I think one of your textbook calls it as tuple variables. I think the other textbook calls it as correlated subquery. Nevertheless, irrespective of the name, this concept is extremely important, right? Throughout the exams and all that, I will keep coming back to this concept, wherein you are passing the tuple variables to the subqueries and all that, right? It makes sense, and make sure you get it right. Okay. So another query. So this is, I believe, yes. So this is also an correlated subquery. You are using tuples from the student relation inside, something like this, right? And then here instead of exists, I am using the word not exists. So that means when I use the phrase not exist, it will check, it will return true if this inner subquery gives an null answer, right? So you're going to loop over every tuple of this student relation, and for every tuple of this student relation, I'm going to evaluate this inner subquery. And while evaluating this inner subquery, I am taking the tuple variable s also, right? And whenever this inner subquery is returning a null answer, then this if this where clause evaluates to true, right? So it's just the opposite. In case of exists, you were checking whether the inner subquery was returning a non-null answer. In not exists, you check if the inner query is returning a null answer. It's just exactly the flip of it, right? Now what is this query and all that, I'll I'll let you figure it out. I have written it in English also, but I'll leave this as an exercise to for you to figure out what is this query doing and how it is doing. Okay. I think this is another one construct. Exist, not exist. This is unique, right? It will check whether the inner query has duplicate results or not. Yeah, it has its uses, but I think in our questions and all that, we are going to use exists lot more, and this kind of things, less than all and all that. This we are using would be using lot more, and this tuple variables also will be using lot more, right? But I think you can read through this. It's quite straightforward. Okay. Last but not the least, subqueries in the from clause. Okay. Let's see that. So here we have this question, find the average instructor salaries of all those departments where the average salary is greater than 42,000, right? Let's see how we are doing it. As always, we are going to start from the from clause, and now let's watch closely what's happening in the from clause here. So the from clause now is itself a query, right? So this is the subquery here. Select department name, average salary as average salary from instructor, group by department name. So this query by itself, what it's going to do, it's going to loop over all tuples of the instructor, and it's going to group them by the department name attribute, and for every group it's going to compute the average salary and rename that column as, or call that column as average salary, right? So the output from the inner query is department name followed by the average salary, right? So if you have 3 departments in your institute, you will get 3 tuples from the inner relation, and for every tuple you have the department name and the average salary of that department, right? So that is what the inner query is returning. Now we can simply use this as our quote unquote data set, or table in the from clause, and now the other portions, select and where, are going to be applied on this result. Now how are we going to do it, right? So result from this inner query, let's say it is stored in some temporary variable, and we are going to loop over all tuples in that temporary variable, and for every tuple we check whether the average salary attribute is greater than 42,000 or not. If it is greater, the tuple passes through, and then you perform the projection operator. Okay? And note that this average salary is exactly this, right? So whatever projections you do here, right, these can be used in your where clause. It's quite intuitive, right? Or sometimes what we do is that when we are working with a lot of tables and all that, you can call the output of this inner query with a different name. You can say that this, the whole thing, as some temporary name, and now whatever select you have written, these becomes the attributes of that temporary relation name. Okay, this is how the from clause works. I think, yeah, this is the example, right? Okay. Note that some of these things may depend on the actual distribution that you are using. Okay, so just be careful when you are using it, but conceptually, yes, this is allowed. The result of this inner query can be stored as, you give it a name and some attributes, and you can use those attributes in your where clause, right? So this is the concept of using subqueries in the from clause. Okay. Yeah, I think we have another query. That's okay. I think you can again, and I'll try to leave this as an exercise. It's pretty straightforward. The inner query is still returning the average salary of every department, and I am storing it as as a different temporary relation called as department underscore total. And now in this now finally I am putting this select max operator. This I am allowed to do because on this particular relation I am not doing any more where clauses. I put max aggregation operator on this column, right. So whichever department has the maximum average salary, that is returned here.